Hey there, everybody, welcome back. Exams are not graded yet. Still got a couple people doing makeup. And I haven't finished grading them yet. As I'll mention in the main class again. So this is actually a question from 2.8. It was on midterm, or similar to stuff on the midterm. F of x is x squared minus 8. And g of x is 10 minus x. Find f of g of -7. Or f divided by g of -7. So you got two choices here. A, we do f of x over g of x first. It's going to be x squared minus 8 over 10 minus x. Then evaluate f of g at -7. So replace everywhere there is an x with -7. -7 squared is 49. And then we have -8. And we have a negative, it turns into a plus. So we get 41 over 17. And both of those are prime numbers. So it doesn't get any better than that. The other option you have is doing f of -7 and g of -7 first. F of -7 is -7 squared minus 8. 49 minus 8, which is 41. G of -7 is 10 minus -7, which is 10 plus 7. 17. And putting them together, f divided by g. That equals our f of g of -7. It's just 41 over 17. Option A tends to be more helpful when you've got more problems to solve. You need to find the results for more than one number. Make sense?
Yeah.
Okay. What else you got? Alright, so for this one, f of x is square root of x. G of x is x plus 3. They want to find fog x and its domain. And B is switch off. All right, so this x here is the same as this x here. So fog x is really f of g of x. And that's the same as my x right there. And there. So when we put g of x there, we're really just replacing what we have. If this is x plus 3, that's g of x. Everywhere there's an x in here, I'm going to put in an x plus 3. So this is just square root of x plus 3 rather than square root of x. Now we need to see where we check g of x's domain. We need g of x's domain and then f of g of x's domain and see the overlap. G of x is just a line, so this is all real numbers. This is a square root, so we need the inside to be greater than or equal to 0. Otherwise, we get complex numbers. So if I subtract 3 from both sides, get x is greater than or equal to -3. It's a circle filled in, pointing to the right. It's -3 to infinity. The overall domain is the overlap of these two. So negative infinity to negative or positive infinity is like that. -3 to infinity is the green line. So the overlap is just effectively the green line. Is the same as, or the overlap is -3 to infinity. -3 is included. I put parentheses there, should be a bracket, because it can equal -3. Then Bach x comes along, which is g of f of x. We have g of x equals x plus 3, and we want to replace it x with f of x, which is square root of x. G of square root of x just replacing that x. This is gonna have the domain, same domain for both of them. F of x, we need the argument inside the radical to be greater than or equal to 0. So 0 to infinity. And g of x has the same thing. I'm gonna put the 3 first, just so it doesn't like get confused. It's 3 is not inside the radical. Again, that needs to be greater than 0. The inside of the radical needs to be greater than 0. So that should be the domain for g of f of x. I want to make sure we hit some stuff from the 3.1. So, as a reminder, in 3.1, we were graphing polynomials. And we started with just 3.1 was quadratics. So for example. Oh, and we would have the vertex. Because we also saw another way of writing this, since A times x minus h squared plus k. So the vertex is at hk. H is equal to negative b over 2a. And k is equal to f of h, which is f of negative b over 2a. I'm off screen. And if we had the vertex, we could go left or right 1 and then up 1, left or right 2 and then up 4. You go left or right 3 and up 9, where the up part is just the square of left right part. Yeah, well, let's see, how do I put this? That's when A equals 1. Let's just look at an example. Change that to 6x plus 8. I want my vertex to be easy. So h equals negative b over 2a. This is ax squared plus bx plus c. So a equals 1, b equals 6, c equals 8. And h equals negative b, which is negative 6 over 2 times 1, which is negative 3. Yummy. So if we want f of h, which is negative 3, just have to plug negative 3 in, and I'm going to use parentheses. Nine minus 18 plus 8. Negative 1. So our vertex is at HK, this is my K. HK is -3, -1. Then we could do the up 1, or left and right 1, up 1. Left and right 2, up 4. What we're going to talk about with this problem. Okay, so we had x squared plus 6x plus 8. What happens if we solve that? Solve x squared plus 6x plus 8 equals 0. You guys had a problem just like this on your midterm. Keep in mind, that's my f of x. We just had that. Same problem we're working on. Well, a is 1, we still have a is 1, b is 6, c is 8. If we do a times c and b, we get 8 and 6. Two numbers that multiply to 8 and add to 6, they both have to be positive. 1 and 8 adds to 9, that doesn't work. 2 times 4 adds to 6, that works. So the way we did this, even without acknowledging a equals 1, is we could split the 6 up into 4x and 2x. and do some grouping. The x plus 2 times x plus 4 equals 0. Some of you stop there, and that's not where you stop. We have to find values of x that work. When we have a times b equals 0, either a equals 0 or b equals 0. Well, this is like an a and this is like a b. So either x plus 2 equals 0 or x plus 4 equals 0. If you can't factor, then let me finish where it's going and it might make more sense, you'll see. But you can use the quadratic formula. That works as well. But this is a lot harder. And you really, if you struggle with factoring, you should really practice it. Because you're gonna need it a lot in later classes. It's a skill. Subtract 2 here, and I get x equals -2. Subtracting 4 here, and I get x equals -4. Setting f of x equal to 0 and solving is called finding the zeros or finding the roots. Now, I don't know where the root terminology comes from. But I know where finding the zeros comes from. If we look at our graph, that point there is -2, 0. That point there is -4, 0. And we got -2 and -4. -2, -4. It's not coincidence. Setting f of x equal to 0 is the same thing as saying set y equal to 0. And when we set y equal to 0, we're finding the x-intercepts. And It's worth pointing out here, when we had our factor form, x plus 2 and x plus 4. X plus 2 and x plus 4 are factors of f of x equals x squared plus 6x plus 8. We're going to do more with that in our main class today, and I'm even going to bring all this stuff up again later on. Now, what happens if we change all this? What if I make it so A is not 1? So this looks just like the other one, but we have it multiplied by 2. Our roots are still going to be at the same spot. Zeros, if I set that equal to 0, we still get x equals -2 or x equals -4 by factoring, and we get -2, 0 and -4, 0. And our vertex h equals -b over 2a. It's -12 over 2 times 2 is still -3. I stick in -3. This is 18, this is -36, this is 16. I get -2. So my vertexes had to shift a little. -9 or 9 times 2 is 18. This is -18 plus 6 is -2. So we have a point at -3, -2 now. But we still have our same points at -2, 0 and -4, 0. Something's changed. Remember when on the other problem with x squared plus 6x plus 8, we were able to go left or right 1 and then up 1. Here we went left or right 1, and now we had to go up 2. Here we went left to right 2, and we were able to go up 4. What happens here? Let's check it out. If I go left or right 2, that gets me to -1 or -5. Let's see what f of -1 is. Six. Which is up 1, 2, 3, 4, 5, 6, 7, 8. See what changed here? We went from 1 and 4 to 2 and 8. And what's happened is there's a 2 in front of it. This 2 is changing how much the y value goes up and down. That's my A. So it's really left to right 1, up 1 times A. Left to right 2, up 4 times A. Left to right 3, up 9 times A. For ax squared plus bx plus c, A scales up how far the up down is, or how much the up down is on graphing. And let's use this to look at synthetic division. So 3.2 had us doing synthetic division. And we're going to do a little bit more of it today. Let's say we had f of x is x squared plus 6x plus 8. It's like with the same graph we've been using. Let's say we did synthetic division of x squared. How did I introduce this? So for synthetic division, we took the coefficients. Or the things in here. Make sure I actually. I know we did a little bit about synthetic division. But I want to look at that lecture note real quick. See if I need to re-hit this. No, I showed it. So what you do to do synthetic division is you take the bottom and set it equal to 0. And you solve, you get x equals -2. And that's what we're going to use, -2. So you bring the first number comes down automatically. We do -2 times 1 goes here. Add those numbers. So we're going to add -2 times 4 is -8. We're going to add, and we get 0. And with synthetic division, we showed this produces a polynomial of 1 degree lower. And maybe with a remainder. The remainder is this portion right here. So f of x had x squared. So this drops down to x. That 1 and that 4. These are both positive. So +1, +4. This gets the x to the 1. This is like x to the 0. So we have x plus 4 after we do that. We divide f of x top by x plus 2. We get x plus 4. With no remainder. That's going to be pretty important. I'm going to do this again in a little bit. Because note, we already knew from our other stuff, we knew the factors of f of x. We did them by hand. But if you don't know the factors, like you can't do this factoring right here, and you do this synthetic division and you end up with something with 0, you find a factor. This shows that x plus 2 is a factor because the remainder is 0. And you'll see it in a second when we do it in the main class. So synthetic division is another way of finding these zeros. It's called the factor theorem. All right, let's take a break till the next class starts. And stop recording.